Today we'll be solving radical equations. Right? What a radical equation is, very simply, is it has a square root inside of it, or as part of the equation. Okay, so these are special equations because there's certain things you have to do and be aware of, and it's very similar to using the absolute value equations that we were doing a couple days ago. All right, so the absolute value equations you had to make sure that the absolute value was by itself before you started solving the equation. In this case, it's the same idea. You want the radical part of the equation to be by itself. Okay, and the reason being is because what you want to do first with these is you want to get rid of that radical sign, and you do that by doing the opposite of what a square root is, which would be a squared. So you're going to square both sides of the equation. And what will happen in this case is that the square root and the squared will cancel each other out. So just be left with what's ever inside the square root sign. Right? If we cancel out the squared and the square root, we're left with 2x. Then we square the other side of the equation. 10 squared is going to be 100. Then we just solve like normal. We divide by 2 on both sides. We're going to get x equals 50. All right, now much like when you had your absolute value equations, the radical equations, you have to check your answers to make sure they work okay. So if you put 50 back in for x, 2 times 50 is 100. The square root of 100 is 10, and that checks out. So we're good to go. Okay? All right, as I said, radical equations are very similar to absolute value equations. So in this case, what we have to do is we have to get the radical by itself. We have to subtract 3 from both sides because we're isolating the square root sign. All right, now that we've done that, all right, now we can move ahead with the process of solving the radical equation, which means you're going to square both sides of the equation. When you square a square root, it cancels it out. You're left with x plus 3, and then whatever 6 squared is, which is 36. All right, then you solve for x by subtracting 3, so x will equal 33. Again, you want to check your answer. If you put 33 back in for x, 33 plus 3 is 36. The square root of 36 is 6, and 6 plus 3 is 9, so that checks out. You can also have quadratics inside your square root sign. All right, so this is already isolated, so you don't need to do anything before you take that first step of squaring both sides. So the squared and the square root will cancel themselves out, and just square the 1 on the other side of the equation. So you'll have x squared plus 12x minus 12, and that equals 1. So in this case, what we have to do is we have to get this to be a quadratic equation, which means it has to be set equal to 0. So we're going to subtract the 1 to the left, so we get this as our quadratic. All right. Now again, I kind of mentioned this before in a different video, but we're trying to be nice. We're going to make sure that the equations we give you can work out pretty simply. So this is factorable. All right. Basically, you need to find two numbers that multiply to give you negative 13. And add up to give you positive 12. Those numbers will be positive 13 and negative 1. Okay, so those are your factors, x plus 13 and x minus 1. So now that you have your factors set up, all you have to do is take them each, set them equal to 0, and solve for x. So your x values will be negative 13 and positive 1. Again, you have to check your answers. So if you put negative 13 back in for the x, you will get negative 13 squared is going to be 169, right? Then 169 minus 12 times 13, which is going to be 13, right? And then your 13 minus 12 is 1, and the square root of 1 is also just 1. All right, same thing if you put 1 in, 1 squared is 1, all right? Plus 12 times 1 gives you 13. And then 13 minus 12 is again 1, so the square root of 1 is 1. So those both check out. Okay. If you're doing the negative 13 in and checking it out, make sure that you put that whole negative 13 in parentheses before you square it. If you square a negative number and you get a negative answer, you've done something wrong. Okay. So negative 13 squared, the whole thing quantity squared should be 169. Okay. All right, moving on. Now we get to a little more complicated versions of these types of problems. You'll notice in the first three, the variable was always inside the radical sign. This time the variable's on the outside, so you got actually two variables, one on the inside, one on the outside. All right, now because the square root sign is already isolated, nothing is being added or subtracted on the outside of it, or being multiplied or divided with it. All right, you can go ahead and do that first step, which is to square both sides. All right, again, the squared would cancel out the square root. So you just get what was inside the square root sign, which would be 5x minus 6. And then x squared is just, well, x squared. All right, so now what you want to do is, again, it looks like we're solving a quadratic. So you want to put everything on the same side. Okay, now at first blush, you might try to say, well, I'll subtract x squared. I wouldn't do that because your x squared term is then going to become negative and it becomes harder to factor. Okay, so what in fact I would do, so I would take the 5x and subtract it, and I'd take the 6 and add it to the right. All right, when that happens, you'll get x squared minus 5x plus 6 equals 0. I just flipped it over the equal sign, so it's something we're more used to seeing. But in fact, that's what I did. I subtracted the 5x and I added the 6 to the right. And then the left side will equal 0. I just flipped it around, so it is a way that we're normally used to seeing it. Now that we have our quadratic, we've got to find out two numbers that multiply to 6 and add up to negative 5. Okay, those numbers are going to be negative 3 and negative 2. So those are your two factors. All right, so then we take our two factors, we set them both equal to 0, we solve for x. So where x is going to equal to 3 and 2. Again, you check your answers. 5 times 3 is 15. 15 minus 6 is 9, and square root of 9 is 3, which is what x equals on the other side. As far as 2 goes, 2 goes in times 2 goes in for x. 5 times 2 is 10. 10 minus 6 is 4. The square root of 4 is 2, which is what the x is on the other side, and those both check out. All right. Now the last two are the most complicated versions. All right, now we have a expression, not just a single term on the right-hand side of our equation, right? But since the square root sign is still isolated by itself, we can go ahead and square both sides of our equation. So again, the squared and the square root will cancel themselves out. You'll be left with x plus 5. However, when you square a parentheses like we are, all right, the x minus 1 has to be multiplied by itself, which is why I've written another one next to it. Okay, that doesn't apply to the square root sign because the square root sign is overriding the expression on the inside of it. Okay, so exponents only directly involve or impact what's directly below it, and directly below the squared on the left-hand side of their equation is the square root sign. Okay, not the x plus 5. All right, so we have to distribute the x minus 1 times x minus 1. Okay, so when you do that, you do x times x times negative 1 times x, and negative 1 times negative 1. You will get this. So the x plus 5 stays the same for the moment. You'll end up with x squared minus 2x plus 1. All right. Again, like one of the previous questions, I think it was the previous question before this one, rather than subtracting the x squared to the left, I'm going to take the x and the 5 and subtract those to the right. So I'm going to subtract x and subtract 5 to get us a quadratic that equals to 0, and it'll end up like this. All right. Now we have our quadratic set equal to 0. We can look to factor it, needing two numbers that multiply to negative 4 and add up to be negative 3. Those numbers would be negative 4 and positive 1. All right, again, we can solve for both of those. X will equal positive 4 and negative 1. All right, then we check our answers. 4 plus 5 is 9. Square root of 9 is 3. And then on the other side, 4 minus 1 is also 3. So that one checks out. All right, for negative 1 plus 5 is negative 4, positive 4. Square root of 4 is 2. And then negative 1 minus 1 is negative 2. Well, negative 2 and positive 2 are not the same thing, so that answer does not work. Okay, so when you're doing these things on the test, you have to indicate like you check them and you know which one works or which one doesn't. You can put a check mark next to an answer. You can put a X next to a different answer that doesn't work. You can box an answer that does work and leave another answer unboxed. All right, the problem is if you just put for this particular problem, as an example, that x equals 4 and x equals -1, and just left it as that, then there's no indication that you know that one of them does not work. So some way, somehow, some shape, some form, you have to indicate that you've checked the answers and that they both work. All right, last one. It is the hardest version, but we're going to go over it together. All right, so now we have a whole big mess. We have a square root on each side of our equal sign. All right, so if you remember from the beginning, we said before you did the first step of squaring both sides, you have to get the square root sign isolated so that it's by itself. Well, the left side of the equation is isolated, the square root of x plus 3, but the right side is not. Now we could say, well, we can isolate the left side by subtracting 1, but then the left side becomes not isolated, and then you have the same problem. Okay, so for this type of problem, all we really need to do is get one of the square root signs isolated. So we're going to leave it just like it is, and square both sides of the equal sign. Okay, notice on the right-hand side, it's 1 plus the square root of x minus 4 all together being squared. So we have a situation just like we had on the last problem where we have two terms that have to be distributed. On the left-hand side, the square root and the square root will go away. We're going to multiply 1 plus the square root of x minus 4 times itself. Okay, so we have to distribute this. I'm going to try and go a little bit slow so you can see how this works and show you all the different pieces. All right, so when you distribute it, you have 1 times 1, which will give you 1. You have 1 times the square root of x minus 4, which gives you the square root of x minus 4. All right, so you've done the first term in the first set of parentheses with both terms in the second set. Then you do the second term in the first set of parentheses by both terms in the second set of parentheses. So you have the square root of x minus 4 times 1. Then you have the square root of x minus 4 times the square root of x minus 4. And this is what happens. So you'll notice that you have 1 times 1 is 1. 1 times the square root of x minus 4 is the square root of x minus 4. Then you have the square root of x minus 4 times 1, which also gives you the square root of x minus 4. And then when you do the square root of x minus 4 times the square root of x minus 4, the square roots cancel themselves out. Okay, it's like saying that you're going to take a square root and square it. It's the same idea. So that means you have just what's inside the square root left over. So that's why the x minus 4 is at the end. All right, that was a lot of stuff. All right, so next what we have to do is combine the like terms. So we're going to take all the terms that are not square roots and move them to the left. So the 1 we're going to subtract. The x by itself is going to be subtracted to the left. And then the -4 is going to be added to the left. All right, this will give us 6 on the left-hand side. The two square root signs that are still left, there's 2 of them. So that's why we have 2 times the square root of x minus 4. It's like if we had x plus x, we'd have 2x. This works the same way. All right. Now the initial rules that we had come into effect. Okay. We can't do anything until our square root sign is isolated by itself. But there's a 2 there. So we're going to divide both sides by 2 to get 3. Okay. Now that our square root is isolated, all right, we can continue on like normal. We're going to square both sides of the equation again. Okay. So the square root of x minus 4 squared, the square and the square root cancel themselves out. You're left with x minus 4, and then 3 squared is 9. We just then add 4 to the other side to get x equals 13. All right, now we have to check it. So 13 plus 3 is 16. The square root of 16 is 4. On the other side of the equal sign, 13 minus 4 is 9. Square root of 9 is 3, plus 1 is also 4. So that does work out. All right, so that was a lot. That is solving square roots. Good luck with the practice, and we should see you on Friday.